Here we're going to look into dimensions of physical quantities. What is dimension of physical quantity? Dimensions of a physical quantity is an analysis that shows the relationship, connection, or association between two or more fundamental or derived quantities. This analysis is gotten from the dimensions of the fundamental quantities. So I'm going to list what we are going to be using here to resolve some questions or to solve some questions on dimensions. The bedrock of other dimensions of physical quantities is on the dimension of fundamental quantities. Now, note this, the dimensions of length is L, capital letter L. Dimension for mass is M. Dimension for time is T. Dimension for temperature is capital letter K. Dimension for current is A, and dimension for luminous intensity is K. Examples: find the dimensions of the following quantities. 1. Area. 2. Acceleration. 3. Force. I'm going to be using this to explain how you can find the dimensions of physical quantities. Here we'll be using dimensions of the fundamental quantities as a bedrock to solving the dimensions of the following quantities. Number 1, we have area. What is the first thing to note? Now, the formula for calculating area is length times breadth. Next, what is the dimension of length? From the fundamental quantity, the dimension of length is what? Is L. Now, what is the dimension of breadth? The unit for breadth is also in meter, which means you can equally use the dimension of length as that of breadth. Now, the dimension of breadth is also L. Now, what is the dimension of area then? Therefore, dimension of area will be L. Length times breadth will give us what? L times L, and that is L square. I believe you understand. The second one is acceleration. 2. Acceleration. Now, what is the formula for acceleration? Now, that's the first thing that should come to your mind. The formula for acceleration is velocity divided by time. Now, do you have the dimension of velocity in the fundamental quantities? No. Now, which means you have to solve for velocity. Look for the dimension of velocity. Now, velocity has a formula of displacement over time. Now, do we have the dimension of displacement in the fundamental quantity? Yes. Here, displacement can also be measured in meter. Therefore, the dimension of displacement will take a value of the dimension of length, which is L. Dimension of displacement is L. Then dimension of time is T. Therefore, dimension of velocity is what? Displacement over time, which is L over T. Now, having gotten the dimension of velocity to be L over T, now let's substitute it into velocity over time. Now here, now the dimension of acceleration will be what? Dimension of velocity over dimension of time. What is dimension of velocity? That's L over T divided by T. And that will be L over T times 1 over T. Then that will be L times 1, L over T squared. Now the dimension of acceleration is LT minus 2. That's 1. Now let me adjust the board so we can. From here, you should be able to understand how to calculate the dimensions of physical quantity using these 3 examples: area, acceleration, and force. Thank you.